Today I would like to talk about how our code in production, how the code we write every day changes with every new C++ version. And I would like to show you that it's beneficial to think about upgrade to new versions if it's possible. Or if you want to move it, but some management in your company don't want to move it, I would like to give some good stuff in your hands to talk with management. So what are the benefits, what are the value-added things in new C++ language versions? But first, please let me introduce myself. I'm called by my friends a modern C++ evangelist. I'm talking about C++ for 10 years probably right now on different occasions. I'm working with C++ code for fun and living, doing this production 15 years already. Throughout this time, I was hosting and I was doing very different roles in my career. I started as a validation lead, but then I started to be an architect for systems, software, solution stuff. I'm right now the chief software engineer, which is actually the principal engineer role in my company because we don't have a PE. I'm also a security champion. And yeah, I'm a trainer, coach, mentor. You can find me on C++ conferences. The small one and the biggest one like CPPCon or C++ Now. Actually, talking about conferences, we'll not have only CPPCon and then the next C++ on C. There will be at least 4 conferences in Europe in November, and we'll have ISO meeting in Belfast, followed by ACCU conference there. So it's pretty close for you. So I recommend you going there. There will be also meeting C++ in November, which is a really great conference. And there are also other ones, like CodeDive in Poland. There will be C++ Core Hard in Belarus. And there will be C++ Russia in St. Petersburg. So I think it's 5 conferences in the neighborhood. I'm also an active voting member of ISO committee. I also contributed some stuff there. I'm most interested with WG14, which is low latency, high performance stuff, finance stuff, the things that Markets is doing here. You can blame my company, EPAM Systems, for fix. Sorry, guys. And I'm also trying to be active in study group 20. This is the group responsible for education of C++. As a trainer and enthusiast, I'm trying to work out the ways how we teach C++, both in the companies like I do for living and also on the universities with students. We want to change the way the C++ is being taught right now, and so we get better engineers getting out from the school. Some time ago, I founded my company, TrainIT, responsible for doing those trainings because I got so many requests for training that I had to make it official. I worked at Intel for 13 years, doing many different stuff there. Right now, I'm working at EPAM Systems. And yeah, looking into the study group 14, probably you already realized that I'm interested in code performance, low latency, but the code first has to be stable and secure. And this is also the subject of today's talk. A long time ago, I won the bench games, but it's a long story. And yeah, it was a long time ago. So let's talk what is C++. C++, first of all, is no longer C with classes that we know from old books of C++, and sometimes also we know from students coming right after these studies, right now from universities, because actually this is what many people are being taught there still, and this is a problem. C++ is a general purpose programming language. It means that if you want to do object-oriented programming, you can, but C++ is not an object programming language. It's just one of the ways you can work there. It's imperative. There is also generic programming features, but the most important stuff is that still you have really close control and access to the low-level stuff. And why we are using C++ in our work? In most cases, it has sense because this is the fastest language in the world. Of course, there are a lot of legacy projects on the market, but sooner or later, those projects probably will not exist, will be rewritten with C#, Java, and so on. But C++ will still be there and will be developed really fast by many companies because it's the fastest language in the world. And this is why we are doing this. This is why this language still is really, really important on the market. So yeah, probably you know the motto of C++ that we don't pay for what we are not using. It's mostly true for all of the stuff we have in the C++ standard and in the library. We have some exceptions there, but yeah, today maybe we'll not talk about them. One of the biggest pain points I have with this is, for example, std pointer. Just don't use it. Yes, and C++ and modern C++. Modern C++ is a thing. It's not a C++ 17. It's not C++ 20. It's not being on the edge of the standardization features. I would say it's a state of mind. It's a philosophy of code design. You have to think in modern C++ way in order to develop good code. I would say that Boost, even though it was created in 2000 something, or probably even earlier, but was really important at the time and fastly developed, is modern C++. It heavily is connected to using templates. Fortunately or unfortunately, it depends how you feel about templates. But templates actually are really cool, and I would really like to talk about them to you. Modern C++ is extensive and wise usage of a subset of the language. Not everything in the language is useful, not everything in the language is good. Thank you, C. It's basically, yeah, because of the backward compatibility with C, we have a lot of strange stuff there, and it's not safe, it's not secure. We are trying to not use that stuff there. And modern C++ is also implementing the code with performance in mind from the very beginning. I don't mean to write a code that's micro-optimized from the very beginning, doing micro-benchmark from the very first day of the project. I mean, don't do stupid stuff from the very beginning. Think about the data, think about memory layout. Because if you will screw the memory layout of your data structures, it's really, really hard later on to refactor. It's so expensive that will probably never happen. So we have to think about data, we have to think about how it works with our CPU, how it works with our caches, in order for our software to be fast, because this is where C++ excels all other languages. It is the fastest language in the world. Modern C++ is really about following the best practices, coding guidelines and idioms. And there are a lot of them, C++ specific idioms. I don't mean gang of four patterns. These are mostly anti-patterns in C++ right now. I mean idioms that make our code really robust. Today we still don't have enough time to talk about idioms, but I gave 2 weeks ago, I think, a whole day, for example, workshop on the C++ Core Hard conference about it. Yeah, and of course, this is the last point here, but yeah, modern C++ is always also about following the latest version of the standard. And this is the subject of today's talk. I will show you why it's useful and really recommended to follow and upgrade to the latest versions. Björn Strostrup in 2007 said that within C++ there is a much smaller and cleaner language struggling to get out. He actually meant C++ 11, he meant modern C++. He meant the new trend in C++ that appeared in the late 2007, 8, something like this, when C++ 11 was standardized. So let's take a brief look on the C++ 11. I would not talk about it too much because probably most of you already know it, probably most of you probably use it in a production already. So let's just highlight the biggest features. We have move semantics, constant expressions that basically are about the performance of the language. We have core language usability. We have lambdas, object construction improvements, explicit final overrides, range-based for loops, scoped enumerations. We have functionality improvements like variadic templates. Finally, we know something about multitasking memory model and threads, because before C++ 11 there was no even single word thread in the standard. We just was agnostic about multitasking and multi-threading. And we get some other stuff, like explicit default and deleted functions, static assertions, and a lot of improvements to the standard library. First of all, threading facilities, smart pointers, more containers, type traits, and tools like regex, chrono, random. Really good stuff there. But you probably already know about it. so we'll not talk much about it today. What I would like to show you that is C++11 was a big change, was a groundbreaking change on the industry. A lot of companies that I work with as a trainer say that we are already on C++11, that's good, and we don't have to move forward. We just make the biggest step right now. Actually, C++11 just woke up the industry. You can see it easily from this graph. This is the graph of our IC++ committee, how we work. This bold line is the number of attendees attending each meeting of IC++ committee through the years. And this dashed line here is number of papers we have to process on every meeting. These are the 2000s. So this is creating of C++11. You can see that it was nearly flat. About 50 people were creating C++11. We have around 50 papers to process on every meeting, even less at the very beginning. But then, see what happened. This gets logarithmic here, it's exponential. C++11 woke the industry. Again, people started to believe that C++ can be good, can be fast, can be useful, and we started to develop our language from that point. The number of attendees from 50 right now reaches nearly 200 on every meeting of the committee. And number of papers, actually, it's about nearly 300 right now. It's insane. Actually, if someone counted number of lines in the papers you have to read before every meeting, and it turned out that every employee, every member of the committee going to the meeting should read more lines that Shakespeare wrote through all his life. And this is even like without counting the IC++ standard itself, which is already like nearly 2,000 pages. This is insane, and probably no one is able to prepare like this for the meeting itself, for the IC committee meeting, because there are just too many papers, too much work right now happening in the industry to move this language forward. As we cannot learn everything, as we cannot move the language in one group, we have to split. At the very beginning, we just had the C++ committee. It was one group of 20, 30, 40 people discussing about the language. But at some point, it was not productive. So we split the committee to two parallel pipelines, for the core language and for the library. But again, at some point, it started to be productive. So we split it in parallel. We have two different layers here. First layer is so-called evolution layer. Evolution layer is responsible for accepting papers from the community, from guys like you, like me, every contributor to the language. C++ is being built by volunteers. Nearly no one gets money for inventing new stuff to the language. So this is up to us in order to make this language to evolve. So evolution groups are about accepting features to find out if the feature has sense for C++ or not, and providing feedback to the user. Either don't bother, don't come again because you are wasting our time, let's say, or we provide feedback. It's great, but please work more on this, fix that, and we'll improve it. Or, of course, we accept it on the first meeting, which sometimes happens. Then a paper, when it's accepted as a feature, goes to so-called wording groups. And those wording groups are verifying if the wording is created in such a way that it's easy and obvious how to implement it by different vendors. So it's so it's possible to implement this and ship it with standard. The community started to be so huge. Right now we have more than 200 people coming to the meetings that we also had to find to create an official direction for the committee where we want to go. And this is also another group that was created like a year ago or maybe 2 years ago, called Direction Working Group, that consists of 5, 4, maybe 6, the most important persons in the committee. I mean, by important, I mean the number of years they serve for us and their experience they have. So this is basically the body that decides what will be the next versions of the language. And the input comes from the community, like us here, and also from so-called study groups, that are groups of experts that gather around specific subject, about specific industry. We have study group for concurrency, that's really active there. We have study group for undefined behavior, for machine learning, education, the new ones, game development, and many, many more. Also, on the last meetings, we also created so-called incubators. It was created I think in the autumn last year. Those incubators even serve as a first step, even before those groups, the evolution groups, just to start providing feedback earlier to the authors. So, for example, until the Kona meeting that was in February this year, we were working with C++20, but incubators already were providing feedback for C++23 features to the users. So they already got feedback, they could improve their papers, and when we'll be ready to move with those groups to C++23, we'll have better papers to review. So, what's the outcome of that work? You can see that C++11 was created by men in many years. It was working on the mainline all the time, on the trunk of our Git source tree, yes? And merging everything on the top is always a problem because you never are able to ship something. Something is always broken, yes? Or something has to be improved, or you have some new feature really cool that is going there. And it was not productive. We couldn't continue this any longer, so we started to ship in 3-year cycles. We have C++14, 17, 20. And we started to work on parallel branches called technical specifications. Those technical specifications are subject-specific, and they are also ISO standards. Maybe not that big as the official standard of C++, but those are official papers provided by the ISO, and they are provided in the compilers. For example, you can use concepts TS for many years right now. And it was actually included into C++20 on last Kona meeting, or some last parts of it, because it was already agreed earlier about it. So this is how it works. You can see many parallel pipelines here, and those arrows here show how we are merging this stuff on several separate meetings in order to ship them in the official standards. C++20 already will have concepts, ranges, modules, coroutines, and we are already working on reflection for C++23. You may ask us, why do we need so many changes? C++ is already complicated. Why to make it even more complicated? Why we have to learn more, yes? It's hard, it may be not productive, it's maybe better to stay on C++ 98 and 11, the smaller language, yes? It's not. Actually, what we are trying to achieve as the community and IC++ committee is to make the language easier, safer, and faster. All of the features we introduce right now is not to make the language more complicated, more hard to use, or more complex in order to learn. We are trying to replace old features with new features that are safer, that are faster, that are easy to develop, and this is what I would try to show you today. I could, of course, go with C++ 11, 14, 17 and show you this is the list of features, this is the list of features, this is the list of features of specific standard. But you can find it on Wikipedia, right? Or there are already a lot of talks about it. What are the features of specific release of the language? So I decided to do it otherwise. I decided to show you how your everyday code that you write in your company, how it evolves with specific versions of the language. So how can you upgrade your code in order to be safer, faster, or easier to maintain? So we'll work on 10 or a bit more maybe examples of small samples that can represent production code, and we'll see how this code evolves with specific versions. So let's start with the first example. For example, we have we want to implement a non-member function template that will allow us pushing a number of different values to vector at once. For example, if you are working with a unit tests or other places, you already know probably that you want to initialize some state of the test. You have to put 20 lines saying pushback, 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 pushback. Wouldn't it be really nice to have it just to provide those values after commas? How to do it, yes? In C++ 98, what we had to do basically, where is my cursor? Sorry, I just lost my control here. Oh, it's here. Yeah, it's here. You had to provide overloads for as many arguments as you have courage to provide, yes. Probably you will end up at 10. But this is what we have had to do before C++ 11. Yes, so probably you know what is next slide. Next slides are variadic templates. Variadic templates limit the number of iterations you have to provide only to 2 functions, which actually make function templates, which actually makes it much easier to maintain, much easier to verify if the code is correct, and much easier to implement for us because we don't have to copy paste so much code. Yes.
And perfect forwarding.
And perfect forwarding, yeah, perfect forwarding also is the C++ 11 features here, and with it we have better, faster ways to forward parameters to functions. However, we started to like those 3 dots so much that in C++ 17 we introduced a new feature called the fold expressions. With fold expressions, you can actually type only one function template that will unpack all of the template arguments pack into one line, which makes it even easier to write, even easier to maintain, and actually it will be much faster to compile. Because this code will not create you, let's say, a recursive number of function instantiations from the template. It will be only one instantiation with all of the function calls here in one function, which makes it much faster to compile. The binary will be exactly the same. It will be optimized out, it will have everything inlined, it will be great. But compile time will be faster. Okay, let's see another example. Let's try to handle time in C++. Let's implement run until function that will just do basic like spin loop, waiting for some timeout to happen. We'll be doing this actively because we expect timeout to be short. This is how we do it in C++ 98. Yes, you have run until that takes some time spec. This is the highest highest generality timestamp on Linux. Of course, this is Linux only. This is not portable. You have to provide nanoseconds from this time spec. So you have to multiply seconds plus nanoseconds and multiply seconds by this value. I don't know, maybe someone will count zeros if I didn't create an error here. Maybe there's a bug, I don't know. You can count. It's hard. And we have this simple spin loop, yes? While true, you have to get time spec again from clock get time. And you have to multiply stuff again with the same strange magic value and compare if the new time is bigger than the timeout. In that case, we break, otherwise we just call run. If you want to run this function, you have to again create time spec because you have to create this timeout. You have once again multiply everything here to create seconds to provide the timeout. Probably it's 300 milliseconds, but still I'm not sure because it probably should be 300 milliseconds. At least it was my intent here. And provide the timeout in that way that you can pass to this run until function that we seen on the last slide. Probably you know where I'm going to, because you probably know C++ 11 chrono library. We have chrono. See, I think that chrono library is the best written library in our C++ standard library. If you want to learn modern C++, go and look how chrono is written. It's the best example how to write really robust code that has no overhead in compile time, runtime, and it's really, really safe to use. With it, you just create run until function that has steady clock, time point, timeout, and you have while clock now is less than timeout, run. That's all. If you want to call this function, you just take steady clock now, and you call run until start plus milliseconds 300. And this is all. This is type safe. You don't have to count all those zeros in multiplications. It's really, really nice stuff. C++ 14 added us here user-defined literals for those, so you can type it even easier. But you probably already knew this stuff. So let's look on how we can handle date instead of time. So what day of the week is July 4, 2001? In order to implement this right now, even today with C++ 17, it's not only C++ 98, it's just we have to do this the same all of the time. until today is you have to provide some strings to provide string value for specific day and unknown if something is wrong. You have to provide and fill the TM struct of Linux. This is again non-portable code. You have to remember that the year is actually indexed from 1900, not from 0. You have to remember about it and subtract it every time. You have to remember that actually month is 0 index, while day is not. Like saving time, you can provide -1 to provide it automatically in order to make it easier for you. Then you can check if this time is valid, because you can provide something like 30th of February, yes, and it will not be valid. So then you have to verify if there is an error. There's an error plus 7. 7 is unknown. We handle just an error, yes, and print it. This is how you have to do it until today. With C++20, or even now, if you will download the library from Howard Hinand from GitHub, which I do for production for 3 years already, so you can use C++20 right now. You have, once again, extensions to chrono, and this is all. This is how you write a weekday of July 4th, 2001. And actually, it will work in compile time. If you look into the binary, you will see something like Thursday. Of course, this will work in compile time only if you have compile time arguments, yes? So maybe it's cheating, but it is so fast and so smart that it can work in compile time. This is how your code starts to be safer. If you are working with finance, if you're working with, I don't know, flights data or some scheduling, and you're working with dates and times, go for chrono and the latest one. If you cannot move to C++20 because it's not there, download the library for Howard Hinand from GitHub and start using it. I was using it for the biggest mercantile exchange in the world like 3 years ago already. So this is also probably something interesting for markets here. If you're not using this, it's something to look at. Really, really good stuff. Really safe. Okay, so let's find out why C++ is the fastest language in the world. It's also because we have so-called negative abstractions layers. So you add more abstractions and you get faster code than without the abstractions. How come it's possible? It's possible with compile time dispatching. How you can do it, for example? Let's assume that you want to implement advanced algorithm from the standard library that takes an iterator and advance the iterator with specified distance. And iterator can be either input, forward, bidirectional, random access, or contiguous. Actually, this is how it's implemented in the standard. It's a hierarchy of inheritance. I don't want to say polymorphic because it's not polymorphic, it's just hierarchy. And this is how it's implemented. So there are tags for each iterator, and you can easily find what properties of the iterators you have. And this is how you do it in C++98. You write an advanced algorithm. If you don't see, guys, there are a lot of places here. So you are welcome to come here. Yes? And yeah, let's write this advanced algorithm here. And what we have to take iterator traits of our input iterator and verify its category. So this will be one of the tags from the previous screen. And then you make a compile time dispatch. If it's input iterator tag, you can move only forward, yes, you cannot move backward. So we provide some assert here to make sure we are only work with positive values. And we make a for loop that will iterate the iterator for that many times. If it's bidirectional iterator tag, we can move either backwards or forward. And if it's random access, we can do it in one step. And then, when it's compiled by the compiler, everything is optimized out, inlined, and you get compile time dispatch for specific type you have right now in the type system. There is no runtime dispatching, there is no overhead of if branches. Everything is as fast as possible. And always safe. Because compilers knows better than you what you're working with. in many cases. If you want to hand optimize stuff, you are always often you can be wrong. You are never sure that you did it right. With C++11, we have a small change, but really important one. We have using aliases that actually I think that typedefs right now should be deprecated and removed from the standard, because using is just way better and way more powerful than typedef. A small change, but really, really nice. With C++17, we have compile time branching by if context. It may not be the easiest to analyze this code right now because we have to provide additional type traits. Is based off random access iterator tag, is based off bidirectional iterator tag, otherwise it will be forward iterator tag. But it's one function and you have compile time branching. However, once again C++20 comes. With C++20, the code starts to be a bit more readable. First of all, we get concepts here in the template specification saying that this template function will accept only input iterators. So you already know what you're working with. Of course, input iterators and better iterators. Yeah? So it has to be at least input iterator. And you can use actually concepts also in those branches. It's not only to do this finesse stuff in the template parameters, you can use it in the branches too. So you can say that if concepts, our iterator is random access iterator, do this. If it's bidirectional iterator, do this. Otherwise, it has to be input iterator. And also you can find here new syntax. It's so-called C++ contract. This is new feature of C++20. I will talk about contracts a bit more when we have better examples for this. But this is assert created with contracts, not with macro. Yes, are there any questions?
I was thinking that sometimes it's preferable to actually dispatch a tag when you, well, here internally it probably uses the tags and see if it's derived from the tag. But if you define your own tags and you check with if const expr it's exactly that tag, then it's not as good as the dispatch, which selects the best match. So here it is, because it's handled for you by the random access iterator thing.
Mm-hmm. Yeah, so basically in case of those examples, this is both cases with tag dispatch and with this compile time dispatch, thanks to if context, are exactly the same, yes? But in some cases it may not be, and it's up to you what you want to use. Yes, I'm not saying that this is better. I'm just showing you how the language moves in order to provide you new features that you can use and how you can use them, yes? So basically we have a lot of things in our toolbox, and it's up to us to know how to use it, yes? So tag dispatch is also great, yes? I'm using it in many places now, and I don't want to say that it's obsolete and you shouldn't use it. No, it's not right. Okay, so another use case are compile time calculations. So let's provide the implementation of some calculation algorithm that will work in runtime and will allow to pre-calculate an array of typical values in compile time. So it often happens that if you have some algorithm, there are some cases where input is more often seen than other inputs. So you can like pre-calculate values for some typical inputs in order to make everything faster. Yes? So with C++98, for example, let's say our expensive functions will be factorial. This is typical university approach here. Everyone probably written already at least one factorial in their life, so this is a good example to show. This is how you run a runtime factorial stuff. You can, of course, run something like this. It will not be a compile time. You can run with value 4. It will not be a compile time. And if you want to do it in compile time, you have to do some meta-programming tricks in order to calculate this in compile time with C++98, yes. You have to provide some class templates and specializations for them in order to provide the compile time facility for it. And the benefit of it is that you actually can use, for example, factorial of 4 value as an array size. You can have pre-calculated values of it. Or you can call this foo function with pre-calculated value. Of course, you cannot provide n here, because n is a runtime variable, it will not compile. But you have to provide 2 different implementations, 2 different algorithms written in totally two different styles. So you are not sure that the implementations are consistent and actually provide the same results for all the values. Those are 2 separate implementations. There can be different bugs in them. So actually, nearly no one did it like this. It's better to use Excel, yes? If you're working at least 10 years in the industry, you probably worked with Excel some time ago. This is what we did many years ago. You just calculated all of the values for the algorithms written in C++ for runtime and in Excel for compile time, and then you are putting values to the code, yes? This is how we do stuff. Again, these are 2 totally different implementations, one in Excel, one in C++ code. We don't know if they are consistent. You probably know where I'm getting. I'm getting to context, of course. So with context, you can have the same implementation working for runtime, the same implementation working for compile time. And this is already good. However, notice that compile time will be forced here when you have compile time context for array size. It will be forced here because this is a context object. It will be forced here for static assert because we also got static asserts with C++11. But here, compile time is not guaranteed. The compiler may choose if it wants to calculate it in compile time or not. If it decides that it already made your life so miserable and the compilation is so slow, it can decide, I will do it in runtime to not make you suffer even more. But if it decides that it can do this in compile time, it will do it in compile time. Of course, if you provide runtime variable, it will be runtime every time. In C++14, maybe what's the difference between factorial 11 and 14? In C++11, talking about the context, we have a list that long saying what we can do in context. This is like a list of things we can do. This was that long. Right now we have that long list of things that we cannot do in this context. For C++14, we can have loops, we can have branches, we can mutate state in context. We can do nearly everything. With C++20, we nearly could provide memory allocations in C++20. Actually, we failed because we wanted to have stud vector in compile time for C++20, but we didn't manage to do it, but it will be for 23 for sure. So with it, you can provide exactly the same implementation that we've seen for C++98 here. And it will work fine in context. Only this is a good driver in order to move from C++11 to 14, if you're looking for good points to talk with your management. Making context functions easier to manage, easier to type, easier to maintain is a good thing to notice here. Yes, there is a question in the back.
Yeah, I think vector is okay. It's not if it's deallocated. No? In context per 20.
As long as the allocation doesn't escape.
I think vector is okay. Like as far as I heard, like vector is okay in context per 20 if it's deallocated, or am I wrong?
Actually, I think that it may be possible to implement vector in that way already with the features we have in 20, but stud vector probably will not be the one. There were some changes needed in order to do it, but I know that some last bits are missing in order to make it compatible with compile time context. But actually how it will work, it will be like this, that a compiler will track allocations in compile time and actually will warn you or provide compile time error when you have a leak, memory leak in the compilation context. So if your class will leak, you have compile time errors that your class is leaking. And you can do it in different context functions. For that we will need the allocators functions, the default allocator functions in language to be compile time, to provide compile time context, and some other tricks provided for the language. Especially tricky here was toString, for example, that provides small string optimization. But we are nearly there. For sure, we'll need std_vector to be compile time for reflection stuff. So we'll have it for C++23 for sure. But right now, I don't think you can use std_vector there. I don't think that, for example, constructor of std_vector is context in the specification right now. But I may be wrong. Maybe it was changed, but I don't think so. If it's not context, you cannot use it. But probably you can write something that is vector-like, that is nearly there already with C++20 features. Yes, question? Mm-hmm.
Does the assert work in the context of a function?
Does assert work in a context of function? Possibly.
Assert as a macro? Probably not. I don't think so. But contracts will work. Contracts will work in a context function. Also, if you have things like instead of assert, you will use things like GSL expect, for example, for writing contracts using GSL. It will work in compile time context because by default they throw exceptions, and exceptions are not allowed in compile time context. So basically, this is compile time exception. With C, yes, continue. Okay, so with C++20, 17, sorry, there are not many changes here, but probably may be useful for you if you're working with arrays a lot. Probably things that bothers you is that you have to provide number of elements every time. So if the array is long, you have to count off the elements to be sure that you provide the same value here as number of initializers in the array. It was bothering me for a long time, and it was the only thing that was missing in order to replace C-style arrays with std array. With C++17, you got class temporary argument deduction guide, and class temporary argument deduction as a feature, where you don't have to provide temporary parameters here, and it will just deduce that those are integers and the size is free. So it's the same as in C-style array here. Also, the other change here is that we just don't have to provide any non-meaningful errors here. We can just keep the comment in the static assert, because I've seen from my experience that in most cases it's just empty braces or error that says everything here. In most cases, just the code here is enough to say what's wrong, and people just don't care and not write anything meaningful here. So C++17 allows us to skip it. Of course, you can provide it still if you want to provide something meaningful to the user, but just don't put errors there. It doesn't say anything. And C++20. With C++20, we can actually move this assert from here to contract. And this is a really cool feature. I'm really looking forward to the contract because, first of all, right now contract is specified not in the documentation or in the implementation of the function like assert. It's in the signature of the function. So if you go to the cppreference.com, you will actually see the contract of specific function there next to the function. Or if you would analyze the header with declarations only, you will see the contract of specific functions there. This is already great stuff to advertise intent of the architect of the function, how this function should be used, what values are expected to be provided to this function. This is great. Another point: this is not a macro. Macros are bad, and we should skip them, especially in header files. Yes?
Yeah, they renamed expects and assures to pre and post.
Not yet.
Yeah?
It was.
I thought they agreed on that.
No, this was on the evolution group, but we expect really interesting discussion on this in 2 weeks.
Okay.
The comment was that the expects and ensures were renamed to pre and post on the last meeting by evolution group, but committee didn't agree on this yet. So we expect an interesting discussion on this, and probably it will not go through on the next meeting. Especially that a lot of wording right now, for example, in the standard specification, is exactly follows this expects and ensures wording. So going with pre and post, it's not compatible with it. Yes?
Just in the +17 or 20 versions of this, you can use the folded compile time, right?
I mean,
In your factorial computation, you use the fold.
fold?
Fold.
You mean fold expressions?
Fold expressions, yes.
Fold expressions for factorial, maybe, if you can write it in this way. If you can find implementation that will work with fold expressions, maybe you can work with it, but I didn't know how to write it with fold expressions, actually. But maybe. Okay, however, we have two columns here. So I wanted to show you another thing that will come with C++20. Because we still have here this issue that if you wanted something to be put in compile time, this one may not be compile time stuff, as I said, because the compiler is allowed to decide if it's compile time or not. However, there will be a new keyword called const eval in C++20 saying that it has to be forced compile time evaluation. The implementation is exactly the same. You can actually use const function from const eval functions. And what is the difference here is that const eval will always be forced to work only in compile time context. So everything here will be compile time, including this one. And as a side effect, the last one will not compile, so you cannot call const eval function with runtime argument.
Does this mean that you can overload on one that is const eval and another one that isn't?
I don't think so that we can overload on those. The same as you cannot overload on a plain factorial function and const factorial function, you will not be able to overload on those.
I hope they would have solved this problem that you can't.
With if const expert is constant evaluated.
It's constant evaluated is totally different piece, and it's really scary to use. Yeah. But yeah, you cannot overload on those, and actually you have to provide two different, for example, names: factorial const eval, or const factorial something underscore something. So you will have to have two different names probably, if you would like to keep both of them. So this may be a side effect here, but if you need something to be compiled you have to be sure, you want to be sure that everything is compiled during compilation and nothing in runtime. So for example, this code will not exist in binary code. If you have something secret, some algorithm that even that shouldn't be in a binary stuff, then go for const eval. Everything will be compiled during compilation, and you have only the output of the calculation in the binary, and the functions, const eval functions will never appear in a binary code of the program. So those are only compile time stuff and will never appear there. So this is one case to use it. Okay, short question to you. Let's do a quick code review. Yes, we have like 2 minutes for code review for each function. Please tell me what this function does and if it is correct. Code review time. Any ideas? Is it easier in this form or this form? Please use algorithms. We have a lot of them. If you are missing something, write one for you with an algorithm-compatible interface. It's so much easier to work with and to prove this is right. Really, the handwritten for loops is the pure evil of our code, and we should really try to limit them, unless they are really, really simple and easy to maintain. So, code that says what is just as readable as code that says how, but we are used to write code that says how because this is C++, this is iterative language. We always wrote the code that says how. But saying what, so doing declarative syntax, it's much easier to maintain, much easier to reason about, and much more likely to remain robust. And declarative style is something that C++ is moving to lately. You can find a lot of talks about it. For example, on C++ now there were quite a few talks about it. Really nice. So, switching to algorithms then. Let's implement getOrder, a function that will return us the iterator to order for a given client ID from a range of orders sorted by client ID. So we have two structures, account and order. Both of them are having client ID field here. Client ID, let's for this example say that it's just an integer. And we have stud vector of those orders. We have some function that gets us the orders from the database, for example. And we have to provide get order for specific client ID. Yes, how to do it? This is how we have to do it in C++98. We have to provide our own comparators for functors that will take order and order for sort. And then you can put it in sort. For get order, we'll be using lower bound, and lower bound actually forces us to provide different interface. It needs order and client ID. So you have to write another functor for it. Yes? And then if you want to use it, you provide const iterator. You get iterator from the get order, provide get orders 1, 2, 3, and use the iterator. If you want to work with other structure like this account, you have to provide two other comparators here. With C++11, of course, you know when I'm heading to, we have lambdas, yes? We have lambda with one signature, we have lambda with another signature. Everything is inline, it's closer to each other, thanks to it, it's easier to maintain. If you want still to work with account, you'll have to provide two other lambdas for those. With C++14, we got so-called generic lambdas that takes auto here. This is another really good selling point of C++14 over C++11. It makes so much easier many stuff, especially algorithms which are cool, as you've seen the code review time quiz, yes? Algorithms are really good and lambdas are really helpful for that, and generic lambdas are even better. When you see auto in lambda, it always means that there is a template inside. Yes, this is automatically deduced parameter from the context. So here we take two structures and we compare clients for them. And here we take client and client ID, structure and client ID, and we compare those for the another case. This will work both for my two structures, for account or for customer. Or order, sorry, order and account. Okay, but can we do even better? With C++20, we can define only one lambda called projection. Projection is how you get how you convert from one type to another. So we say here how we get client ID from any structure. So we find this client field or member in specific type. This is projection of type to client ID. With this, we can provide new stud ranges sort, provide stud ranges less, and provide two client ID as our projection. So see that right now we just separated what we are comparing with information how we are comparing. In previous lambdas that I had to write by myself, I have to find out where is client ID in the structure and to provide comparison that is less or less equal or something like this. Here I'm saying I'm using standard tool here less, and I'm just providing the projection that is written by me. It's the same like we are having iterators to not work with containers and algorithms to work easier with containers and algorithms. So this is some abstraction that helps us in order to better reuse our code. And we have here get order. And right now, actually, with C++20, we can provide contract of type audit. That means that this contract is pretty expensive to calculate, so it probably shouldn't be verified on every build, but you can verify it, for example, in some debug build to make sure if it's right. Because actually, our get order, if it calls lower bound, it assumes that the collection is sorted. So it's good to say, at least for the user, that it has to provide sorted collection here, or maybe check it even from once at a time in the debug build to make sure that actually no one forgot about sorting it before providing us the data here. And with this, it's much simpler, it's much shorter, and we have better code reuse. Yes, because we have only one lambda that works with all of two structures for all of two use cases here. So this is how contracts, how ranges library and will help us with it. Actually, I'm showing you the slide for a longer time right now, and there is a bug here. Did you notice it? Where is the bug? We have get orders that returns you the orders, so the vector of orders by value. Then we have this lower bound here that returns us the iterator. Yes, the iterator is stored here. This is get orders. That gets the R value, so the temporary of orders here. We have iterator here, and then we use it in the next line, where our vector is already destroyed. This is a really typical bug that will happen in production. Already happens a lot, but will happen even more when we have ranges, probably. Actually, this code would not compile if you would be using algorithms directly in this code. The problem comes with our own encapsulation of this algorithm with our own function here. Because we lost the type of it. We don't know if it's R value or L value, and we are passing just always L value to this algorithm. With L values, it will work always fine. So either it will be recommended for C++20 to work directly with algorithms in your code, or make your wrappers also templates that will perfect forward the data to the algorithm in order for it to know if it's working with R values or L values. In this case, you will take a compile time error saying that there is no match for operator star in a strange type called dangling. Yes? C++ machinery, C++ metaprogramming found out that here we are calling getOrder with R value, so a temporary, put this temporary with a perfect forwarding to our algorithm, and algorithm said, okay, I cannot be just working, I never will work correctly with a temporary, so instead of returning iterator type, I will return something strange called dangling that doesn't have any implementation there, so it will not be able to, for example, call operator star or operator this arrow for pointer semantics on it. It makes us compile time safety here. Of course, if you want to fix it, just make get orders, store it in an L value, provide L value here, no error, everything is safe. You get iterator, you can dereference it. These are the features we try to implement in the language in order to make it safer for you to use. Okay, we have like probably 3 or 4 more examples. So the next example here is range processing. Let's print the age of first n adult persons in any range of persons. Any range, I mean like any container, yes? Person, let's say it will be easy. Name and age as strings because we got it from XML or JSON or anything that's strings, yes? And you have vector of those person called people. And you have a function called print age of first n adults. In C++98, you will have to write hash written loop, where you have to provide input range, const iterator, and begin and make the conversion from the string to integer to verify if it's an adult, verify if it's only n first adults, and print it. Actually, this code works with every container here, but not with CRIs. For CRIs, you have to provide another overload and because this for will not work fine because there will be no .begin in C array. With C++11, it's a bit better because you can use range-based for loop, which actually will work with C arrays. And you can also static assert for some really strange stuff. If begin of people relative as an iterator, that iterator traits will say that the value of this iterator is person. So you make sure that the any range here actually is the range of persons that you want to work with. I expect that probably no one from you will write it in production code because it's just too complicated. But it's good to check if you are having a template like this, taking everything, because it will take everything. It's called input range, but it can be string, it can be float, it can be double, it can be collection of anything. It's good to check it's actually a collection of things that you expect it to work with, yes? Actually, plain templates like this, template type name T or input range, the name is really not important here, it's just void star of C++. Another change here with C++11 is that we got new utility called S2E, yes, S2I. So we can convert string to integer here. Let's move to 17. With 17, we have small changes here. The one thing is that we have variable templates used for type traits. This is really small change here. Another change is that we got really fast utilities to convert from strings to integers and back. They are called from cars and to cars. If you're doing conversions from string to integers and back, I really recommend you going for those functions because those are the fastest possible conversions that will work for you.
If you just Untitled for loop, it's about twice as fast. I mean, last time I tried.
Is it me?
The last time I tried it, if you just write if you handwrite a for loop to just convert integers, is about twice as fast as from chars at least with Clang. I mean, it's still much faster than ATOI and so on because it doesn't use the locale information and so on, but it's still not particularly performant, or maybe I did something stupid.
Probably had written for loop. You can write it, probably. Maybe it will be even faster if you know exactly what is the format. I'm not sure if from cars can analyze if it's format in hex or decimal. I don't remember exactly what specification. Maybe it has some additional branches there. I'm not sure. But maybe, yeah, handwritten for loop sometimes may be faster, but probably also sometimes will not be, let's say, as universal as this one. But actually, from all of the standard functions and utilities you have, this is the fastest one you can use. There's nothing faster there for you to use that will work in a universal way. If you need something handwritten, handcrafted for a specific format, because you know, for example, that your numbers will always have like only up to three letters, then maybe you can write something faster. But if you want to make sure that it's universal for any strings, any integers, probably this is the fastest one. With C++20, actually, we don't have to provide this big static assert in that way, yes? This is where I'm heading, saying that type name T is the void star of C++. We have concepts. With concepts, we can say that something here has to be input range, and actually that the value of this range has to be person. I assume that it's much easier to maintain, much easier to understand than this static assert here. Also, the static assert on the previous screen was in the implementation. This one is in the declaration. Once again, go to the cppreference.com and you see exactly what's expected. This is contract of template programming, so concepts. You provide all of the information here explicitly in the code, in the function signature.
Yeah, the concept version is definitely much better, but you could have done it in the signature before using Spinner, like enable if.
Yes, we can do it with enable if and Spinner, but it's still, for some cases it's not possible. If you want to find specific use cases, find my talk about physical units library, because for some cases you cannot just do Spinner there. You cannot do spinner, for example, on a return type. You cannot do spinner on class template parameters. And with concepts you can. And still, it's much easier to do with than spinner. And yeah, what's next? Next is we provide here projection to age from person, how to get age. We just do toInt of our person age, and also we provide some comparator. What does it mean for someone to be adult? Age has to be bigger than 18, yes? And see what happened here. Here we have so-called ranges. We have for loop that takes our container of people and will transform it to age. So from on this pipe, we already are not working with vector of persons. We are working with value integer of age, because this is asynchronous. So it will never create a vector of ages, let's say. It will just work with simple value one by one. It's asynchronous code. It's delay execution, yes? It's lazy execution here. Then we filter only adults based on this lambda, and we take only n first elements. If I will right now print here the task that we are trying to implement here, and you will compare it with this statement, it will be exactly the same nearly description. This is declarative syntax. This is how we can write code that not what, but how we do it. Sorry, not how, but what. Sorry, I'm already tired. So yeah, so basically what we are doing here, we take people, we transform age to the person to its age, filter only adults, and take first n elements and print it. And this is really powerful, and it will just compile time to the same code with all the optimizations later on. Right now, still, this is experimental features. The implementations are not that good, and the compiler optimizers are not that wise of those new patterns, but they will learn it, and it will be as fast as handwritten loop at the very beginning. And actually, this is the only way to do it properly, because if you will try to use algorithms here, you would have a lot of problems with performance. It will not be exactly the same code. So this is not about algorithms, it's about ranges. If you would like to have algorithms and create here the transform algorithm instead of transform range here, then you will have here vector of persons, then you have to provide vector of ages in order to transform from one to another. So you have to allocate new container inside your function, which will be costly. So it's not that you can easily replace every for loop with every algorithm. Yes, but with ranges you have another way of replacing handwritten for loops, because this one will never allocate. Okay, let's go to another example. Let's write a simple wrapper. A wrapper like pair, like optional, or any other. That will just take the art of writing good wrappers is to make them easy to use. Actually, when you are working with pair and you want to return a pair of two strings, you would like to initialize it this way. Yes? Just provide two strings, or string literals in this case, and initialize strings here. And this will be implicitly, those string classes will be implicitly created to strings, and those strings will be implicitly used to construct a pair. But for vector, for example, of it, you wouldn't like for it to be implicitly converted from value 11 to 22. Even though the vector has the constructor taking one integer, you wouldn't like this syntax to work. It will be really, really scary for developers to write a code like this. So you want to have this, you don't want to have this. How to do it? Right now you have to create the same constructor twice. One is explicit, one is implicit. And there is a bunch of enable ifs and finale stuff. Yes? The beginning is the same. Is constructable, And the last part is the negation of the first case. It's convertible. And basically you have to copy-paste the implementation of two containers into the constructors into those two functions. Water? I have one here, thank you. With C++ 14, it gets a bit easier, but not much. We have those underscore T helpers here. With 17, we have underscore V helpers, but it's still not much easier. With 20, we can actually work with concepts. With concepts, we can provide a requires clause instead of spinner here, enable if, saying that we require that the first overload has all of those 4 things true, and the other one has only 2. With concepts, it will be that more specialized concept has more priority. So this one will be selected if everything is true, otherwise this one will be selected. However, this is still not that fine, because you still have to provide the implementation of this constructor. So we provided new feature in C++ 20 called explicit operator explicit, that will just take bool expression here saying if it's explicit or not. And this huge code from the very beginning that probably none of you will write for your own wrapper function in your company starts to be really easy to write for everyone. Probably this code like this could be found only in Boost in stop.dat library. I'm pretty sure that if you have any wrapper types in your companies written by your engineers, they will not have this semantics, because it was just too hard to implement. Yes, this was that hard, and it was really not, let's say, talking about return of investment, it was not the best way to invest your time. With this, everyone will be able to write it soon. Okay, let's look at another example. We have select strings. We want to compare them. For example, let's call it as case-insensitive string, for example. For the sake of implementation, just use string here. And even using just wrapper, doing wrapper over string that has all of the functions there, you have to type all of those by yourself. This is copy-paste code. You even don't know how many errors I've seen in this code in many companies, because it's too easy. When code is too easy, we make errors. When code is complicated, we care, and actually we don't have errors there. We have errors in the code that is too easy to write. We make so many copy-paste errors here that you cannot even imagine. And you have to type it. You have to type it to compare two strings with each other. You have to compare strings with const star and const star with our string. In all ways. With C++ 20, you will have a starship operator. There you will be able just to write comparison with other string or with const star. And this one will work both for left-hand side and right-hand side. Only one implementation. It makes everything much easier to write strong types. There was a talk before me saying that we tend in C++ to use integers for prices, quantity, and other stuff. We do it basically because it's really hard to create a wrapper by ourselves. We don't have strong types in the language, and without strong types, we have to provide all of those operations by hand, and often we just don't want to write all of this code by ourselves, and we just stay with int or double. With starship operator, it makes it easier to create wrapper types by ourselves.
Does it have to be a member function, or can I write a free function that could work with, say, an enum class?
I think that it can be, of course, free functions too, non-member functions. But probably in most cases, for enum types it will not be the case, but for most cases it should be probably friend non-member function. Actually, this is the pattern that you should use always for comparison operators, that you should friends even if you can compare stuff with the public interface of the function. This is a feature called hidden friends that makes everything much faster for operator in case of Jesus. How it's called. ADL, yes, too. Yes, ADL. Maybe I'm going to then look at overload resolution. Yes, sorry. I'm getting tired, sorry. Overload resolution will be much faster because in case of overload resolution, you will not take 200 types that has operator equal and try to find which one is the best. You will take only this one for the specific type. And also this one will not trust all other comparisons that you already have there. So if you want to speed up your builds, make friends everywhere. Even if it's not needed by the public access. Because overload resolution actually is the slowest part of our compile time stuff. It's not templates. It's overload resolution. It's the slowest part of our C++. Another simple example I wanted to show you is how to write a simple string view. We have two string views, Alabama and Mississippi here. We create a simple for loop that we take begin for both of them, and we want to print the common beginning of both of them. So as long as we reach end and increment the pointers here. I don't want to look into the implementation because this implementation is pretty trivial. I just have pointer size. It has a constructor that does good stuff. It has size and begin end, and it also has const iterator that also does a pretty trivial stuff like operator star plus plus for pre-increment, post-increment, and operator equals and not equals. What actually is important here, that even the first slide here had a bug. Can you spot the bug on the slide?
The comma in the condition part.
Yeah. And the bug is that we have a comma here. Things like this are really hard to find during code review. And this code compiles fine, but it just doesn't work. Yes? So I would like to put your attention on C++ 17 feature called no discard. Right now, even there was a thread on internal mailing list of IC committee, no discard all the things, like context all the things. You probably know those stuff. Right now, we're talking about no discard all the things. Basically, we have wrong defaults for everything in C++. We have to provide more specifiers right now than the code for our classes. And it sucks, but really with those specifiers the code gets better. See, no discard, context, no except, and where is the code? Also explicit probably for constructors, yes? Jesus. But with that, if you put no discards in these places, you will get a compile time error saying that you're ignoring return value of this first element here, because you wanted to provide here two ampersands instead of comma. And the code gets much safer and everything is checked in compile time. No discard is really a good stuff to work with. C++ 17. I think that there are only two last cases here, so please bear with me. I want to implement custom hash map. We want to make sure, like all of the containers, that we are doing this right. So we are using empty-based optimization. So if our predicate, hash, comparator, allocator, deleter, whatever we have as our policy-based design here is empty, we don't want to pay size for it. We just want to make it disappear in size of the class. So we are using empty-based optimization. And how we are doing this right now? We are having so-called EBO helper. This is a class template that has boolean use EBO. Type T is not final because we cannot inherit from a final class. And we inherit only if it's empty, because otherwise it doesn't have sense. This class template has two specializations, for true and false. If it's true, then we inherit from this type T. So if we inherit from it, we benefit from empty-based optimization. So basically, we will not pay for additional size here. And if it's false, we put a member here. So we are not using empty-based optimization. And the rest is trivial pretty. We have constructor that will here initialize the base class, here will initialize the member, and get function that will just get this, because the pointer of base class is the same as the child class, and T in case of the member. With this, to implement such a function, we have to provide those EBO helpers for every parameter from the template of our container. We implement this in case of private inheritance, because it's implementation detail that we just want to use EBO here. And provide some helpers in order to be able to use it in the hash map. That's a lot of effort to save like 3 bytes here. Yes, but that's what we do in quality libraries. A lot of effort, and probably most of, again, corporate code will not use it because it's just too hard. With C++20, we will have no unique address that will just say, if hash predicate or allocator is empty, I promise you, I will never take the address of those members, so you don't have to increment the address on each of the objects here. Probably we'll also get compile time error if you try to do it, but I'm not sure because I didn't have possibility to play with this feature yet. So you don't have to write any EBO helpers, you don't have to inherit privately from anything, you just provide information that if it's empty, I don't care about its address. And last thing for today. Check if provided integral value is legal value of an enumeration type, or stated otherwise. Please provide me string value of enumeration. How many two-string functions of enumeration did you write in your life? Everyone did it, yes? And you have a lot of them. Two-string, 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 enumerations of other types. So we have enumeration. Fruit, apple, banana, orange. Is valid fruit. Value is either apple, banana, or orange. If you provide is fruit 55 because it's the input from user, it will not be a fruit, yes? We write this code really, really often in our production code. It's really hard to maintain because we often add new types here, new elements to the enum, and we don't update our functions. A switch without default can help with it, but sometimes it's really hard to maintain that. In C++23, I hope, we'll get reflection. With reflection, you will write only one function called is1 of enumerators and one function called toString in your code, and that will be O. You will have probably something similar to this thing, calling that will do for context for loop on something returns from this reflex operator on enum type. Reflex operator on enum type will provide you compile time information about the type. Enumerators will return you this compile time vector that I mentioned with enumerators, information about enumerators in enum type. And then you can for loop in this in compile time context and compare if the value of enumerator is the value that you get as an argument here. If it's yes, it's true, otherwise it's false. If you would like to make toString function, you will not compare here values, you will just say user string or user text, something like this. There will be different text because there will be mangled name, unmangled name, and user-friendly name that you will be able to get from those structures. And you will have only two functions, toString and isValid enumerator in your code, and it will work with every enum type, and it will be probably faster than any handwritten code you will write, because the compiler will know all of this stuff, will do all of the loop unrolling stuff and all other things and tricks in order to make it fast. Yes, Phil?
There is a library called Magic Enum that I think works with C++14. It's not completely standard, relies on fairly widely used extensions, but will actually give you most of this.
Great.
C++14. You can get some of it if you do it yourself, even in C++11. You should check out Magic Enum.
Magic Enum. Things to check. Yeah, I will have to check it because it's, I'm tired of writing those functions. But Basically, this would be a cool feature. Probably this would be the biggest feature of C++23. And pattern matching. Yeah, so with that, I know it's already late and we are tired, so let's finish those examples. I could follow those a lot more. We didn't talk at all about modules, we didn't talk at all about coroutines, we didn't talk at all about stud format, and many other good stuff that comes with C++20. C++11 was a game changer on the market. As I said, a lot of companies said, we moved to C++11, that's enough, and we are already modern, yes? You can see how much code, starting from C++11 until 17 or even 20, how much it changed with the changes we introduced to the language. 14 and 17 provided us really meaningful changes, that there were meaningful improvements in the standard, but they were not that huge as C++11. We got generic lambdas, we got those improvements to the context functions, we got types like string view, optional, and variant that I cannot live without in my code right now. But basically you can find some of those types in libraries on GitHub, and maybe you can live without C++17. However, C++20 is coming fast, and it will be huge. It will be, I think, even bigger than C++11 was, talking about the influence on the code we write every day. With C++11, yeah, we can write almost always auto, so it will change nearly every line of our code, but we don't do it. Variable templates are fine, but probably you don't write them too often. Lambdas are great, but probably you also don't write lambdas in every function of your code, yes. But with C++20, we'll have features like concepts, like contracts, that actually will apply nearly to every function template and function you write, in order to make the signatures easier to understand between architects and users. And it will automatically make our code safer. We'll have a lot of other features that we talked today. It will be really game changer on the market, and we should start preparing for it. Also, try to get some features from C++20 already. You can get stud format from the GitHub. You can get a date from Howard Hinand from GitHub. Those things are great. And basically, when this released, you will just modify the prefix to std, and the code will remain the same in the production. So, do not stay behind. Try to follow what we do in the committee. Try to follow the conferences. If you would like to learn more about this modern C++, contact me or any other C++ trainer. And we can come to your company and provide the talks for your engineers, for your managers about modern C++ and why to improve the process or versions there. So if you'd like to stay connected with me, this is my website. There are also some visit cards here on the cupboard if you would like, or find me on LinkedIn or on the conference. Thank you very much. Do you have any questions? Yeah, we had a bunch of questions in the meantime, so probably everyone's waiting for a beer. See you then. Thank you.